All right, Algebra 2, this is a little extra from lesson 4.2. So I'm talking about lesson 4.2, and this is that lesson where we were talking about like x to the third times x to the 2k minus 1, all of that to the third. So remember here, we would have to multiply. So this is just x to the third times x to the 6k minus 3. And now when I multiply, I add like terms. Well, a 3 and a negative 3 are just going to cancel out. So the answer to this is x to the 6k. But what I'm finding is my students are really struggling with questions that are equivalent. So let's look at this. I'm just making it up in my head. And, oh, let's not do that. I'm totally talking to myself, but you guys don't care, right? Okay, so here I have 3 to the 2x and 3 to the third, 4x plus 1. Well, remember, if I have a power to a power, the first thing I'm going to do is multiply. So this is saying 3 to the 2x is equal to 3 to the 12x plus 3. Notice we have the same bases of 3. If I have the same bases, I can take the 2x and the 12x plus 3 and make them equal to each other because we have the same bases. So now I'm back to Algebra 1. 2x equals 12x plus 3. And because I made this up in my noggin, it is not going to work out perfectly. When I divide by negative 10, I get x is equal to 3 over negative 10, or negative 3/10. All right, we're going to try one more of those. I'm going to take one from the book, so maybe it will actually work out. Let's do 3 to the 5n is equal to 3 to the 5 times 3 to the 2n times 2. First thing, we have a power to a power. So we're going to rewrite everything that we see, except we're going to solve that power to a power, which is 4n. When I multiply the bases, I add the exponents. So now I have 3 to the, well, I probably should write it as 5 plus 4n. And remember, I can make these equivalent to each other because we have the exact same bases. So 5n is equal to 5 plus 4n. When I subtract 4n to each side, n is equal to 5.